What I am currently holding is an unusual and rare type of greenish feldspar known as Amazonite. While this mineral is not the topic of this video since it was found in Colorado, I want you to still note its crystal structure. On the opposite hemisphere, there is a strange and currently erupting volcano which also produces abundant large feldspar crystals, but the variety of feldspar it produces is not Amazonite. The volcano I am referring to is Moutn Erebus in Antarctica, which has been continuously erupting since 1972 and contains an active lava lake. This volcano mysteriously produces unusual elongated crystals which are often between 1 and 6 inches in length. Known as Erebus Crystals, they are found around the summit area of Moutn Erebus. This is quite unusual as it seemingly goes against the general rule of how large magmatic crystals form. Generally speaking, large magmatic crystals form within a deep magma chamber as their massive growth occurs in part due to the unusually long time it takes for the crystals to cool. Before I explain how they form, I will first describe what exactly Erebus crystals are. Due to the unusual geologic setting of Moutn Erebus, it produces a wide range of highly alkali-rich lava and volcanic rocks. One of these highly alkaline lavas is a rock type known as phonolite. However, unlike normal phonolite, there is a subvariety that erupts at Erebus which has unusually large crystals of feldspar, being part of a rock type better known as Kenyte due to its occurrence also at Mount Kenya. Within this rock type are large feldspar crystals whose specific variety is known as anorthoclase. The chemical formula for anorthoclase is sodium-potassium in parentheses, indicating that the two elements can substitute each other, followed by aluminum, 3 atoms of silicon, and 8 atoms of oxygen. Just like the Amazonite shown earlier, these crystals have a so-called triclinic crystal structure. This means that not only are the lengths of each of its 3 axes completely different, but also the angles between the axes are all not 90 degrees. Although it is still somewhat unknown how these crystals form, I might suggest that some mechanism is cooling lava fragments in 2 stages, as the lava these crystals are found within are porphyritic, which has 2 differently sized groups of crystals. The larger crystals were the first to cool and did so slowly deep under the volcano. The finer grained material cools much more quickly, most likely after being erupted onto the surface. Reaching the surface, gas and pressure might finally push the phonolite lava upwards, resulting in a strombolian eruption which ejects bombs of lava in a several hundred-meter radius. This deposits glassy bombs of molten rock around the summit of Erebus. As the lava bomb cools, the small crystals develop as it cools quite quickly. Next, since the glassy portion of the lava bomb easily erodes away, all that soon remains is the much more erosion-resistant crystal. And this is how the highly unusual Erebus crystals are found around the volcano. Thanks for watching. If you would like to request a specific topic, please leave a comment below. Additionally, I would like to thank my new patron Patrick Healy for supporting this channel.